Okay. A dozen is 12. A mole is 6.02 times 10 to the 23rd. This is a big number. Unimaginably big. You cannot imagine how big this number is. I'll give you an example of the size of the number. If you started counting at the beginning of the universe 14 billion years ago, and you counted every second since the beginning of the universe, you would be less than 1/10 of 1% of the way through this number. That's old. And that's a big number. Unimaginably big. You can't picture in your head how big this number is. But it's just a number. 12's just like dozen means 12 every time. Mole means that number every time. A dozen eggs is 12 eggs. A mole of eggs would be 6.02 times 10 to the 23rd eggs, which would be more than the mass of the sun. So, big, big number. Okay, but still just a number. Okay, the things we're going to count are the little pieces. You get a big number because you got little pieces. And what we're counting are atoms. Because atoms are kind of tiny. Well, think about the bell work, or the homework last night. It was not a random thing that I assigned you number 43. Look at what it says the mass of an atom of gold was. Something times 10 to the minus 22nd grams. That's a tiny number. But if you get a mole of them, they're going to weigh something. So we need a periodic table. I'll give you an extra one so you don't have to pass one back. We need a periodic table. So this is your copy of the periodic table. Keep it with you. The one you use on the test will look just like this, except it probably won't be bright orange, because then I can tell you're using mine, not yours. Okay? Okay, first, to qualm any fears. Do I have to memorize the periodic table, Mr. Green? And my response is, I got my degree in chemistry. And every time I took a test, they handed me a periodic table. So if I can get a degree in chemistry without memorizing it, do you think I'm going to require you to memorize it? Nah. But you're going to have to use the heck out of it. There's tons of information on this table from the shape and location of where they're at. That's one of the things we're going to do, is what this table tells us about how things behave. Right now we only need one thing, and that is the decimal number underneath the symbol. Okay? That decimal number underneath the symbol is how heavy 1 mole of that would be. Okay? So if you look up carbon, carbon's symbol is C, number 6. If you look at it, you see down below it says 12.01. Everybody see the 12.01, number 6 over here, carbon, says 12.01. That 12.01 grams is how much 1 mole of carbon weighs. So if you had 12 grams of carbon, there would be 1 mole of carbon, which would be 6.02 times 10 to the 23rd pieces of carbon. So I start off with how heavy it is, 12.01 grams, and I figure out how many pieces there are. Because I have just written that 2 things are equal to each other. And once I've written that 2 things are equal to each other, what can I do with that information? I can make a conversion factor. Just like I can go from centimeters to hot dogs and grams to atoms, I can go from moles to atoms. Because I got 2 things that are equal. So what we've seen on this screen right here is the mole is equal to two things. It's equal to the grams off the periodic table, and the mole is equal to 6.02 times 10 to the 23rd pieces. So if I start off with grams, I can figure out how many moles. And once I figure out how many moles, I can figure out how many pieces. That gives me a way of counting atoms, because the other way is not going to work. If I gave you a piece of carbon and said, how many atoms are on here? Do you think you could count how many atoms there were? For two reasons. One, they're too small. And two, you don't have enough time, because the numbers are going to look like this. To have that many pieces of carbon, you only have to have 12 grams. The weight of 12 paper clips. Mr. Green? Yes. Okay, we'll do. Okay, bye. So, let's try some problems. This will be up on the web. Okay. So how much would 2.34 moles of carbon weigh? So 2.34 moles of carbon. Want to get rid of moles of carbon. Whatever this unit is, it's got to go down there at the bottom. It's kind of a trend we've been following for the past week, right? What can I turn that moles into? I can turn that into grams of carbon. I could also have turned it into atoms of carbon, because I know how many atoms there are in a mole too. But they asked me for grams, so I'm going to turn grams. And 1 mole is 12.01 grams. The moles cancel. .34 times 12.01 equals, I got 28.1 grams of carbon. So all we did was find another equal statement and then do exactly the same math. Right? So it's not new. It's the same stuff. We just got something else that was equal. We didn't know how many atoms there were in a mole. Now we do. So how many moles of magnesium in 4.61 grams of magnesium? So how many moles of magnesium and 4.61 grams of magnesium? Okay, one of the biggest trick on this is not to be confused by manganese, because both manganese and magnesium are on the periodic table. So you define magnesium, it's number 12. Okay. And when I look magnesium up on the periodic table, it says 24.31 grams is 1 mole. Everybody okay with where I got the 24.31? It was right underneath mg on the periodic table. It says 24.31. So now I want to get rid of grams of mg. And grams of Mg I can turn into moles of Mg. And I just looked up that 1 mole of magnesium was 24.31 grams. The number next to moles is 1. The number next to grams is how heavy it would be, a bigger number. So 4.61 divided by 24.31 equals, I got about 3 digits here, so I want about 3 digits of my answer, so I put 0.190, because that's 6 rounds the 9 up to a 10, which makes it 0.190. And it was what, it was 0.18963, so when I look here, there's a 6, that makes that a 10, which makes that a 9. Okay, and the units are moles of magnesium. Now you'll find that I always write the chemical afterwards when I'm doing these, because eventually we're going to write a conversion factor that changes the chemical. Leaves the other pieces there and changes what chemical you're talking about. So right now we're changing the mole part of it into a gram part of it. Eventually we're going to turn the magnesium into something else. So that's why I always make sure I write the stuff afterwards, is because I know what's coming. Later on, we're going to change what's coming, what the other half of it. So that lets us answer questions like, how many atoms in 1 gram of lithium? If you had a gram of lithium, how many atoms would there be? So, what unit do I want to get rid of? Grams of lithium. They want atoms. Can I turn grams into atoms? No, but I can turn grams into moles. Right? So I'm going to put moles of lithium up here. And 1 mole lithium on the periodic table, number 6, is 6.94 grams. It's number 6. They go in order. So, everybody see the 6.94? Number 6. Oh, sorry. You know, I'm thinking, it's number 3. You're right. It's number 3. Number 6 was carbon. Number 3, 6.94 grams. Grams of lithium are gone. But I don't got what I want. So what unit do I want to get rid of? Moles of lithium. Where's it got to go? On the bottom. What can I turn moles of lithium into? I can turn it into atoms. Because what is a mole? A mole is a whole bunch of pieces. 6.02 times 10 to the 23rd atoms is 1 mole. Notice you don't have to decide whether you're going to multiply or divide. It's the problem puts the numbers where it tells you what you're going to do with them. So I type the 1 divided by 6.94 times 6.02 EE 23 equals, my calculator gets me 8.67 times 10 to the 22nd atoms. And that's a pretty big number. Well, let's think. A billion is 10 to the 9th, right? So a billion would be 10 to the 18th. Still 1/10,000th of this, because you're still 10 to the 4th off. These are really, really big numbers. Okay? That's great as long as we're talking about elements, because these are all the elements. The whole universe can be built out of this. But there's more stuff in the universe than this, because those elements get together to make molecules and compounds. So what do I do if I've got H2O? Well, what does H2O mean? 2 hydrogens and 1 oxygen. Everybody okay with that? It's 2 H's, 1 O. So if I had 1 water molecule, it'd be 2 H's and 1 O, right? If I had a dozen water molecules, I'd have 2 dozen H's and 1 dozen O's. Does that make sense? What if I had 1,000 water molecules? I'd have 2,000 H's and 1,000 O's. What if I had a big number? What if I had 1 billion water molecules? 2 billion H's, 1 billion O's. What if I had a really big number? What if I had a mole of water? Then I would have 2 moles of H and 1 mole of O. It works just like dozen. 1 dozen waters would make 2 dozen H's and 1 dozen O. 1 mole of H2O is 2 moles of H, 1 mole of O. Because a mole is just a number. Just like the dozen, the 1,000, the billion, it's just a number. I just do it a mole of times. So, a mole of water molecules is 2 moles of H atoms and 1 mole of O atoms. So I can't look up H2O on the periodic table to figure out how heavy it is. But I can look up H and O. Okay? I can find the mass, and if I want to figure out how heavy 1 mole of H2O was, I'm not going to find H2O on my periodic table, so I'm going to have to get it a different way. That's what this sentence is about. This is the first step. Determine the moles of elements they have. Water is 2 moles of H, 1 mole of O. I'm thinking about what it's got to be. Let me write down a little bit lower. 2 moles H, 1 mole O. Then figure out how heavy that H and that O would be. How am I going to do that? Well, what we just did. I want to get rid of moles of H. I want grams of H, and 1 mole is, I find H on the periodic table, it's number 1, and it's 1.01 grams. So my H is going to weigh 2.02 grams. 1 mole of O, well, this is pretty trivial, but a mole of O weighs 16.00 grams. Because underneath O, it says 16.00 on the periodic table. So that is 16.00 grams. So if I had a mole of water, the hydrogen would weigh 2.02 grams, and the oxygen would weigh 16.00 grams. So how much does the water weigh? Just add those up. So water would weigh 18.02 grams. So for a compound, you figure out how heavy all the pieces are, and then you add them up. It's kind of like taking a car, weighing every single piece. Well, actually, my friend worked for Boeing, and his job was to weigh airplanes. There are no scales that will hold the 300,000 pounds that a 747 weighs. So how do they weigh an airplane? They figure out how much every piece weighs, and they add them all together. Because they can weigh the pieces of the plane. Well, that's what we're doing here. Water is made up of 2 moles of H and 1 mole of O. The H's weigh 2.02, the O's weigh 16, the whole thing weighs 18.02. Is that right? So what is the mass of 1 mole of CH4. So, I said I won't find CH4 on my periodic table. So I got to look up the things I can look up. I can look up C. And how much C is there? Now, how many C's do you have in CH4? There's only one C in CH4, right? It says 1 C and 4 H's. So 1 mole of C would weigh 12.01 grams. Got that number off the periodic table. Looked it up. How much H? It says CH4, so there are 4 moles of H. And I look up H on the periodic table, it says 1.01. So 4 times 1.01 is 4.04. So how much does CH4 weigh? 12.01 plus 4.04 is 16.05. So notice where we're at. We're at a mole is this many grams. I can make conversion factors out of that. So what we've just made by adding those numbers up is the conversion factor for grams and moles for CH4. If it's an element, I can just look it up. But if it's a compound, I have to add it up, make my own conversion factor. I can't just look up the conversion factor. I have to add it up so I can make my own. Does that make sense? Because think about, they could list every possible chemical. You would spend more time trying to find it since there are billions of chemicals. You spend more time trying to find it than you would figuring it out. Okay, the technical term, the generic term for a mass of a mole is molar mass. It means the mass of 1 mole. So if something asks you for the molar mass, they're asking for the mass of 1 mole, not how heavy their back teeth are. So what is the molar mass of Fe2O3? Well, how many FEs? 2. And I find Fe on the table. It's number 26. I thought it was 26. I didn't want to guess this time. I don't have it memorized. And look up Fe, it's 55.85 grams. And 2 times 55.85 is 111.70. How many O's? It says 3 O's. And look up O. We already looked up O. O is 16.00 grams. So 3 times 16 is 48. So the molar mass is those two numbers added up. 111.70 plus 48 is 159.70. And that is how much 1 mole of rust would weigh, because rust is Fe2O3. And now for the rust of the story. So I got grams and moles. I'll be able to make a conversion factor out of it. And where you're going to run into that is in questions like this. how many moles is 5.69 grams of NaOH? We answered one a lot like this earlier. We went, how many moles is so many grams of Li or of C? I could just look up the number then. But when I go to do my conversion factor here, I got 5.69 grams of NaOH. Not a good learning position. And I know I want to go from grams to moles, right? We know that's what we want to do. And I know the number in front of moles is going to be 1. What's the number in front of grams? Can I look up NaOH on my periodic table? No, but I can look up Na, I can look up O, and I can look up H, right? So for NaOH, the Na on the periodic table is 22.99 grams. It's number 11, I think. The O, we've already seen, is 16.00 grams. The H is 1.01 grams. So 22.99 plus 1.01 is 24, and 24 and 16 is 40. When I was in high school, I had that number memorized because I took chemistry without a calculator. And we had to use these molar masses all the time. They like NaOH because you can do the math real easily without a calculator. I wouldn't want to have to do the math. It's tougher to do the math with 159.70 than it is with 40. So he picked sodium. My teacher picked sodium hydroxide as his favorite chemical because it made the math easier. Okay. I didn't have to multiply any of these by numbers because each one of these was a 1. If there had been a 2 next to O, I would have had to multiply O's number by 2. Okay, just like I did in the last ones. And so that grams is how much 1 mole of NaOH weighs. So 40 grams is 1 mole. So what you're adding up is the number you put next to grams. You're building your own conversion factors. So that? So that's what I'm going to have you do tonight. Practice this, taking some numbers off the periodic table, then using them to figure out how many moles you got, how many grams you got. So, oops, that's way too many. I'm going to make the other side of the room. I passed Bunchy on the next row for you. Don't worry about her. We'll forget about her back there. Okay, don't just put the paper away. I actually want to point out a few things that's going to save you time. Because I don't want you to waste your time. Because hopefully by now you realize I wasn't lying when I say if I waste your time, I wasted my time. Need one more? You got it right here. You need one too? There you go. Okay, so if you look at the first 8, it asks you to find the mass of 1 mole of each. So if it's an element like oxygen, you're just going to be able to look it up on the table. If it's a compound like hydrogen peroxide, you're going to have to add it up. Does that make sense? Then down below it says, how many moles is 22.3 grams of O? It is not random that I picked oxygen there, because it's the same as number 1. You already figured out how many grams 1 mole was for oxygen up in number 1. In number 2, they ask about hydrogen. Number 10, they ask about hydrogen, because number 2 is hydrogen. So the ones on the top and the ones on the bottom are the same chemicals. So figuring out the mass of 1 mole up here is going to let you answer these down here. On the back side, I got just the question, and you have to know to do both steps. Is that okay? Make sense? This is one of the most common conversion factors we'll use all year. Have a pleasant one.